Hi, welcome. We're really excited to see you all here, and we're really grateful for the reception for our demo this morning and all the interest in Google Wave. It means the world to us to finally get to share our product and get feedback on it, and especially to have you guys start developing with it. We've been talking to a lot of people today, and probably the most common point of confusion is whether or not Wave is built as a browser app. There's a whole lot of people who are asking where to go to get the download and how the client app works. I think it's partially because we use the term client on our own team a lot to describe the web client, but it's a full browser app, JavaScript, CSS, HTML, all standards and protocols, and most importantly, the whole point why you're all here, it was built with the Google Web Toolkit. And if Lars wants to run up on stage because he was going to introduce Adam, that's totally fine with me. I was going to do my best Lars impersonation, which essentially, what'd you say? Yeah, no, come back up here. Which is essentially to say at the beginning of our product, I think he was somewhat of a Google Web Toolkit skeptic. And over the course of development, seeing how much it helped us, what we were able to do, he's become probably the #1 fan, and it was really important to him to sort of feature it in one of our tech talks. And Adam is the spectacular engineer who's been leading this effort and one of the tech leads on our client side. So I think Lars can do a little bit of an intro and then hand it over to Adam.
So I just want to say everything that Steph said, plus Adam is one of the best engineers I've ever worked with. Give him a hand, please.
Thanks very much. Hi, everyone. My name is Adam Shook, and I'm one of the 2 tech leads on the Google Wave client. You've all seen it today. Hopefully, everyone caught the keynote. Did you think it looked pretty good in the client? Give us a clap if you think so. Yeah, okay. So we've got a lot going on in this client, and I'm going to mainly be talking about today how we developed the process. So today I will talk about to GWT or not to GWT, the decision our team made on whether to use Google Web Toolkit for this project. And as Lars mentioned, when the project started out, I was very much a skeptic. I'll briefly go over the architecture of our client, but just the bits you need to know. The changes in Google Web Toolkit that have occurred over the last 2 years since we started using it to make it possible and really easy to write Google Wave. I'll also talk about improving gears, the work that our team has done to think past the browser's current abilities. Performance, very important to everybody. I'll show you the mobile client, and hopefully this time, since I'm using emulators, we'll actually get to see something happen. And yeah, you were all competing for the wireless. Shame on you. And the testability, I'll talk about very important stuff on to write an application of this scale. You need to know that it works, and you need to be able to move forwards without constantly dealing with bug fixes. And to do with testability, I'll talk about a tool that we had as much to do with as we did with Google Web Toolkit called WebDriver. We've got the creator in the audience, Simon Stewart. And the WebDriver is an automated testing framework. So what are the requirements of the Wave UI? The first requirement, it's got to be fast. If anything we've learned, so I used to work on Google Maps before I worked on Google Wave. If anything we learn, fast matters. Fast is the #1 feature, and people will use your product more if it's fast. Stunning. It's got to be amazing. You want to look at it all day. Thinking beyond the browser. As a team, we decided we didn't want to, and you probably heard this earlier today, we didn't want to think, what can we do today? We very much had a mindset on the team of what do we want to do? What will we be able to do 2 years from now? Because we knew we wouldn't be done tomorrow. And the last point I've got there, optimistic. This needs a bit of explaining. A key design principle we have throughout our whole system is what we call optimistic UI. We don't want you waiting for the server to acknowledge before you can get on to the next thing. So you can write a wave, and before it's reached the server and you've received an acknowledgement, you can be writing your next wave. We're all about speeding the experience up for all of our users. We don't want you to wait. And so this we call optimistic UI. And I'll give a very quick demo since, well, let's face it, it's so much fun to show the demo. Don't spam me too much, but if you're in the crowd, you want to say hello? So some of the things that we did that we probably wouldn't have had time to do if it was JavaScript, like this layout management, resizing, this wave here, which we made earlier today. I can open multiple waves at once. Great. So I can be chatting with one person and looking at my to-do list in another. We put a lot of work into this panel management, like drop downs. We've got drag and drop. You saw it all earlier today. And this nifty little scroll bar, which we're quite big fans of. So let's continue. Oh, back to the beginning. So very early on, a bit of history of the project. There were 5 people working in a very dark room over in the Sydney office. We had no windows, and we were developing a prototype of Google Wave. And this prototype, we were a bit back to front, and we actually built the client in Java and the server in JavaScript. I don't know what we were thinking. And my background, I had just come from working on Google Maps, and I was doing pretty well with JavaScript. I enjoyed it a lot, and Lars says to me, hey, come work on a Git project. And at first I found Java rather constraining. And I'm not going to tell anyone that suddenly I love Java. This is not about the language. So that was the prototype, and just want to give you a bit of background to explain some of the key concepts to Google Web Toolkit. The first concept is you write in Java, and it compiles down to JavaScript. So it's not applets or anything like that. It compiles down to optimized JavaScript. And of course, what that means is you can use your favorite IDE. So Eclipse, IntelliJ, so refactoring, debugging, modern programming, things that JavaScript's playing catch up on. And something we really liked, you can share the code between the client and server. Some of you may have gone to a talk earlier today on concurrency control. Under the hood it was called, and we talked about our concurrency control algorithms. We didn't want to have to write that module on the server and then rewrite it on the client, and then every time you make a change, you've got to make 2 changes and testing and blah, 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 blah. So we wrote it once, and we can use it both on the client and the server. And in the client, of course, it compiles down to JavaScript. Another key concept to Google Web Toolkit is deferred binding. This is something that allows you to, via configuration, depending on what locale, what browser, etc., that your user hits your website on, what code to serve them. So if they're using Internet Explorer, serve Internet Explorer specific code. Don't waste time with Firefox, which of course means that you don't need to do runtime checks of if Internet Explorer do this, if blah, 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 blah. We kind of like that. For the most part, our project prefers to not think about what browser we're working in. So that's deferred binding. And the last point, which I'll be showing how we've got a lot of mileage out of, is JavaScript Native Interface, or as the Google Web Toolkit team calls, JISNI. And this, I love the name. I was so happy when I found that out. This allows your Java code, you write a native method, and we'll see this a bit later, and your Java can call your JavaScript. So should you actually want to interoperate between other APIs that were written in JavaScript, you can. If you want to tinker under the hood, hey, I wasn't happy with how Git implemented it, but of course you will be, you have that ability. So that's just a very brief background on Google Web Toolkit. So history, as I mentioned, we gave a prototype. And back then, I was very much a fan of JavaScript, loved it. And this will sound like an infomercial. I apologize. I was the #1 skeptic of Git. And I wrote up this big document at work of all the things that Google Web Toolkit was lacking, which I will be going into. And I'm happy to say that every single point, and all these things I didn't even think of, have very much been addressed. We've been working very closely with the Google Web Toolkit team to make Google Web Toolkit the tool that you want to use. So what changed my mind actually was Bruce Johnson and Joel Weber. They came down to Sydney and they said, oh yeah, we don't like Java either. I didn't say that out loud. And they showed us everything that the Google Web Toolkit team was planning. And the reason they chose to make it like that is because tools for Java are just, they're really there. Okay, another point about Google Web Toolkit. It's a common myth that you can't build a real application with Google Web Toolkit. I hope we've disproved that today. And also another point is mindset. Lars talked about this earlier, that we felt that when we started using Google Web Toolkit, we stopped worrying about the browser quirks, trying to worry about saving every last byte. Back in Maps team, we'd write var me equals this, because it compiled a little bit better. You didn't have to think about any of that, and it allowed us to think at a higher level, functionality we wanted. So, Scrolly, the panel management, these are all things that we probably wouldn't have had time to think about if we were down at the JavaScript level. That's just an opinion, but that's what we found. Okay, so a very quick look at some of the pieces of the client. The first thing is at the bottom, we have a communication stack on the client and the server, and at the very bottom is a bidirectional communication channel. So we use a hanging HTTP GET request, and this allows two-way communication to be done without constantly having to start a new TCP connection. So we don't need to worry about the three-way handshake. And this is all part of Make It Fast. The next point, so protocol buffers it's open source now. It's a key piece of Google infrastructure. This is how we pass data around the entire company between services and systems. And so we define a protocol buffer specification, and we came up with our own kind of custom compiler from this that generates Java files. And what it does, this diagram, it's a little detailed, but at the top level we generate an interface, a Java interface that is representing that one message, and then we have two subclasses of it. One is the server subclass, one is the client subclass. And each of these is optimized for the particular environments they're in. So server side, we just pass around protocol buffers in the wonderful world of Google. And on the client side, the most optimal thing to do is to use a JavaScript object, which actually compiles out. And thanks to Google Web Toolkit, we generate the interface, we generate implementations, and we have libraries, which I'll mention later, libraries which operate purely on the interface and don't care. They're completely agnostic to which implementation we're using. This was a huge win for us. So we have a concurrency control stack, which was talked about in the Under the Hood talk, and hopefully some of you caught the previous talks today on other things that you can do with the client, extending it with gadgets, with extensions, and all the technology related. A lot of people have been asking this. So what are the supported browsers of Google Wave? This is where we are today, and we hope to really push on this. Currently, we support Firefox 3, Safari, and Chrome, and very much in development, Internet Explorer 7, Android, and iPhone. And you all saw what Android and iPhone looks like today, so we're doing okay there. And before everyone asks, my favorite browser wasn't supported, it's not that Google Web Toolkit doesn't support your favorite browser. It's that we decided we want to optimize for the lion's share at this point, and we believe it shouldn't be too hard if we want to support other browsers. Okay, so I mentioned that Google Web Toolkit wasn't the tool, it wasn't good enough for our users when we embarked on this big project. And it is now. So I want to go through some of the problems that we face with GWT, and then what the solutions are. What was GWT missing in late 2007? So the areas for improvement, late 2007, the UI code was cumbersome, hard work writing UI code. Cross-browser CSS. So GWT wonderfully abstracts away the JavaScript quirks of the different browsers. But my big complaint was, but hang on a minute, most of the quirks come from differences in how CSS is done on all the different browsers. And that wasn't handled at the time. JSON handling, heavy-handed. So if you want to handle JSON, you end up creating all these memory references. The debugging environment wasn't quite the browser, so we'd end up not there'd be bugs that we couldn't actually check in the debugging environment. Monolithic compile. One of the key principles of Google Web Toolkit is your Java code gets compiled into one big file. Mentioned yesterday at the keynote, there was this lovely graph that went up of the client code, and then it went. That was our project, so I'll be talking about that in a bit. So this single file with all of our code was just getting larger and larger, and we didn't want to cut features. So fortunately, Git team to the rescue. And also inefficiencies in the compiler. There's lots of ways that the compiler could have been better. First point, the UI code. I have to write how much code? So creating widgets, time-consuming and heavy-handed. This is what it looked like back then to write a UI widget. So this is some little panel that pops up. Please identify me by, and you can see, blah, 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 new div panel, vertical panel, identify, very tiresome. Turns out there's a really nice language for writing UI code. It's called HTML. We didn't like writing this whole Java thing. So this was something I had a lot of trouble with coming from the JavaScript world. Today, we can use UI Binder. So there's an example of the code, UI Binder, and it looks remarkably like HTML, except it's got some magic references that hook it up to the Java code. And there's a link. I do intend to make sure these slides are publicly available if you want to click on all these links. And what's really nice about this is now our UI designer can actually edit our code. But, if he doesn't want to learn Java, I'm sure he's really good at Java, but sorry, Cameron. He can just hop right into the HTML, the CSS, and play around. So, tick. Next point. But most cross-browser bugs are CSS. So, as I mentioned, Git abstracts the JS quirks away at the Java level, but not the CSS. So, solution. Style injector, CSS resource, client bundle. What does this provide? Well, we get validation. So I refer to CSS classes from my Java code. I misspell it in the HTML, in the CSS file, I will get a compile error. If you live in the world of JavaScript, that's a huge win from compile, build your app, test it in the web, and then 3 weeks later someone writes to you, hey, I can't click your button because there's something in the way. Minification and image spriting. So you can write big, long CSS class names, and we, the Git team, I'm not a member of you yet, crunches it down to shorter names so that the download's better. Image spriting. So many people might know that modern browsers have a 2 HTTP concurrent request limit. So if you're loading 100 images, you've got to wait for 2 to be done before you can get the next ones going. Thrown in for free, Google Web Toolkit will sprite all your images together into a single image and deconstruct it with very little effort in the code. Something I really like, leading a team with a lot of client developers, is it allows modularization of CSS. We found at one point we had a 4,000-line CSS file. No one knew how it worked. I think Lars still did, but and now we can actually store the relevant CSS in the same Java package as the code that uses it. So now we have lots of little CSS files scattered around the place. Now we can maintain a CSS code. And another thing that I'll mention later when we talk about run async is because it's globbed together with your Java package, when you download that package dynamically with run async, then it also downloads the CSS. So you don't download any CSS you don't use up front. And something that makes life easier, to the developers in the room who write client-side code, hands up if you've ever lost a few days or maybe even a few weeks to that CSS code that worked perfectly in 9 browsers but not the 10th browser. That's a lot of hands. Google Web Toolkit lets you write, using the deferred binding principle, we can see the example there, at if user agent Safari. So, hey, I couldn't get it working for the 10th browser. That's OK. I'll just special case that 10th browser. So here for Safari, we add the WebKit border radius. This saves us a lot of frustration. OK, next. Inefficient JSON handling. Previously, JSON handling was inefficient, required a lot of extra JavaScript objects. You don't want to use too much memory in your client. The solution to this is called JavaScript Object, and I'll be referring to that as JSO for the rest of this talk. JSO is a magic type that the compiler knows what to do with, and you subclass JavaScript Object to create what's called an overlay type. And so the tip there is avoid using the JSON object class, rather use JSO and string buffer. That way you avoid the extra memory references. So what you're looking at here is what I referred to earlier, JISNI, JavaScript Native Interface. You can see two methods, both with the keyword native, and what looks like a comment is actually JavaScript code. And so this code here, which is referring to a JavaScript object getting the JSON values, will actually inline. So whenever you call set payload or get payload in your code, the JavaScript will inline that all the way to operate directly on the underlying JSON value. So this saves us in compile size, in the compiled size, which, of course, the smaller the download, the quicker your users can get it. Next, debugging in Eclipse rocks, but each browser behaves slightly differently to hosted mode. So at the time, if you developed in Linux, so this is late 2007, if you developed on Linux, you could only debug in Eclipse using Firefox. If you developed on a Mac, you could only debug in Safari. If you developed on a Windows machine, you could only debug in Internet Explorer. But hey, I don't want to have 3 computers on my machine. I'm guessing a lot of people hear that as well, if you care about cross-browsers. So what's really nice is the new solution to this called UFM, Out of Process Hosted Mode. It's a browser plugin to debug in Eclipse. It runs in the real browser. So this means that I can be developing on my Linux workstation, and I can connect to Internet Explorer on a different computer, or Firefox on a different computer, or the same computer. And on top of that, you can use all your usual tools like Firebug. So now we actually see how it really behaves in the real browser. And the key advantage of this compared with the wonderful world of JavaScript is most JavaScript developers will develop their browser of choice will be Firefox because Firebug is the best tool out there. I hope that's still true. And so what if you actually want to inspect the DOM for that weird quirk in Internet Explorer? Well, you've got to learn how to use the Internet Explorer tool or this browser or that browser. So currently, UFM allows you to debug in Firefox, Safari, Internet Explorer. And there's a link. And I would like to ambitiously try to give you a demo of this. And I'm not going to be able to today. I'm afraid the network connection's a bit slow. But I'll show you a brief glimpse of what you'd be looking at. So we have Eclipse here. Oh, the second I closed it, it started working. So this is Eclipse. This is actual Google Wave code. And I set a breakpoint in Search Wave. Let's see if I can actually get it going again. There we go. Takes a bit of time to load because what's actually happening is the Java bytecode is running between this browser sitting on this laptop right here and a computer down at the Googleplex. So it will take a while. Ignore that. Okay, it's got a connection. It will take a few seconds to load. But I'll just take you back to Eclipse. So, familiar environment, using an IDE to develop a web application. Hooray. And so I've set a breakpoint, and we're going to be able to step through. And of course, because it's Eclipse, I can refactor code, shuffle things around. I'm reminding you all how an IDE works, which is kind of silly. But, I can follow through on different things. And let's see if that's loaded. Might come back to that in a second. But what I'm going to show you is I've set a breakpoint. You're going to see the actual Google Wave client load in my Firefox browser. And then when I click a certain button, the breakpoint will hit. And so I can step through and inspect values. And hopefully I'll be able to get to that a bit later. Okay, but for now, I'm going to go on. Next point. Do we have to distribute Google Wave as a CD-ROM? We keep adding features. If you ever met Lars and Jens, they love adding features. And you saw this morning, we packed 3 billion features into that demo. But hang on a minute, if I add features to client code, I'm growing and growing and growing and growing the download size. This graph here, what you're looking at is the size of our compiled download over time. And the y-axis, if you look here, let's see if I can do this. 1 million bytes. And it looks like we hit something like 1.2 million bytes. That's pre-gzip. But the point remains, we want to keep developing. We don't want to have to go, hey guys, you're going to have to stop working on your project because we're too big. And very fortunately, the Google Web Toolkit team knew what to do. So we don't have to distribute it as a CD-ROM. Rather, we use run async, which is dynamic loading of code. So GWT run async, it signals a cut point to the GWT compiler. So it's pretty much, the whole thing's taken care of for us. It's really quite simple. So you download what you need when you need it, which, we don't need people to download gadgets code if they haven't used any gadgets. We don't need, what are some other ones? If they haven't even opened a Wave to edit it, we don't need the Wave code yet. All of these kind of optimizations. What's really nice, I referred to style injector, CSS resource, etc. earlier. The resources come with the code that uses it. So images, only download them and they come down automatically, magic. And messages, so for, we send down the string constants. They come down when the code that uses it is sent to the client. And it's automatically handled by a GWT compiler. So run async is a signal to the GWT compiler. And here's an actual extract of some code from inside Wave. And you can see on new Wave clicked and gwt.runAsync, and in the success of runAsync, Wave creator.create new Wave. So somehow the barrier between the outside of that method, the caller, and inside, the create new Wave, these are now going to be in separate JavaScript fragments, and that will only be downloaded when this method is hit. And here's our happier state today. So we've gone down and to the right. You can see it's starting to creep up again, but we've got more work to do. So this jump was a very initial introduction to run async, and then a lot more work put in. And this very last jump was actually not run async, but I'm going to show you right now how we did this. So through just using run async, it looks like we got it down to about 400,000 bytes. Let me see if that demo overloaded. No, it seems to me that if I close the console, it will work perfectly. So the next question. Now that we've got it down to 400,000 bytes, which is still enormous, how do we cut it down smaller? We need to know where these bytes of JavaScript are coming from. And how do we do that? We need to know what Java corresponds to the JavaScript. The solution that GWT had to this was story of your compile. So these are reports that show the correspondence of the Java package to the JavaScript in your application. And already we've had tremendous gains from this in the Google Wave team. We identified that the messages that we send between the client and server were far too large. We discovered that the compiled class names, so our internal project name is Walkabout, and up until this, we fixed this, throughout our code you would see com.google.walkabout everywhere, and I keep thinking to myself, the whole app would have been a lot faster had the project name just been the letter W. And the other thing is we needed to identify what's in the initial download of the client. And I'm going to show you what this looks like. And first warn you that we're looking at some reports from several months ago, and Story of Your Compile has had improvements since then. But this is the Story of Your Compile dashboard before that jump I just showed. So if we scroll down, so run async. I'm showing you the SOIC report from here, and then I'll show you the after here. Where was I? So this is the before, and immediately, first thing to notice, size of initial download, this is pre-gzip, is 348K. And the full code size, and that's including some redundancy, but the full code size was 1.3 million bytes. So already we know how big the initial download is from this report, and this is an ordered list of the packages that contribute the most to our client. And you can see here the top row, taking up 152K, is com Google Walkabout common communication data, which is our messages, the message objects that are automatically generated by the protocol compiler, which I talked about earlier. So we play the game on the Google Wave team of we take the top line of this and we make whoever wrote that package feel guilty until they make it go down. And then now there's something else at the top, boom, 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 boom. So I'll show you the after shot. So we did a project which I'll talk about in a second. And here's the after shot. Good team. So we did a project which managed to pretty much cut out the messages from the initial download. And the important thing to notice, top right here, size of initial download just went down from 347,000 to 179,000. Thank you, SoyC Reports, for telling us what we needed to do. So this is something that you don't get with traditional JavaScript development. So that was incredibly useful. So now let's talk about what we did to get rid of those messages. Great. So I mentioned earlier we have interfaces, and then we have the client implementation, the server implementation. The client implementation before JSOs existed, the JavaScript objects existed, was actually storing the fields separately. So we'd take the JSON that got sent from the server, and then we'd create an object, and then store all of those fields again. And so we ended up paying a big price in the code size because we have a lot of different types of objects, and we have very repetitive-looking code. So to be able to actually make these messages completely inline out, get the compiler to do the hard work rather than us, we want to use JavaScript objects. But at that point, JavaScript objects could not implement an interface. So we very much knocked on the Gwt team door, hello, and we got them to come up with a solution. And just to remind everyone that we need interfaces for our messages because of the client and server. They both use the common libraries, the concurrency control. We also represent all the data objects in a common package with interfaces. And we want them to operate without knowing that there is a client and a server implementation. So the solution to this, the Gwt team implemented single JSO impl, which is to say, so a constraint of JavaScript objects is that the reason that they're able to inline in the JavaScript is they make a few restrictions on what you can actually do with classes that implement JSO, subclass JSO. And in order to inline them, the JSOs cannot have polymorphic dispatch, meaning we can't have more than one class implementing this interface because then we've got to look up, hey, what kind of implementation are you using? So the single JSO impl allows us to have precisely, or at most, one implementation of an interface in our client. And so this project allowed us to inline and completely remove, well, knock down from the top row the messages. So this was huge. Okay, so that's a lot of stuff. Thank you, Gwt team. This is a list of what I've just talked about. So declarative UI and UI binder, so make the UI code easy to write. Style injector, CSS results, compile time checking in your CSS. JavaScript object, compile out your JSON representation. UFM, which I always like to be optimistic. Let's see. I'm sorry, people. It's the coolest demo ever, seeing me step through code in an actual browser. And run async, watching the graph drop instead of go up constantly. Story of your compile, which allowed us to identify where all the JavaScript was coming from. Single JSO impl helped us get it down even further. And I didn't talk about this, but Gwt team, they're always coming up with these nice little improvements. I mentioned that we discovered that our package names, our class names, were constantly being repeated in the code. And we thought, well, we'd like to get rid of that. And they just added a flag for us, X disable class metadata, done. And now saved us 90 kilobytes. So another great improvement. And there's always great improvements coming out of the Gwt compiler. So that was very much the Gwt part of the talk. I'm now going to talk about some other aspects of the client. Now I'm going to talk about how we improve the user experience. First thing I want to talk about, when we started embarking on this big journey of building Google Wave, Lars and Jens, big visionaries, they said, where are the browsers going to be in 2 years from now? They didn't say, what can we do today? And so to augment the functionality that we had in browsers at that point in time, we worked with the Gears team to add extra functionality to do the features that we really liked. So you probably saw in the demo this morning, dragging of images into a wave, and they just appear, which is wonderful. I think people find photo sharing a lot more complicated than that nowadays. So that was using Gears. So client-side thumbnailing, we actually create a thumbnail using the Gears worker pool and send the thumbnail to the other client before the whole image is uploaded. So your friend over in another country can now start seeing your images before they're even uploaded. And we had to do cool little optimizations like this, but maybe they can click on the one thumbnail and then, okay, so we'll tell the other client to start sending that one to the server first. So that's using Gears. Desktop drag and drop was also using Gears. And resumable uploading. So we built some things into Gears. And at this point, we very much want to see HTML5 be a great success. We're all about the web here at Google, and we're working towards having this functionality be a part of HTML5. Next, performance. It's got to be fast. How do we make it fast? Now, don't underestimate the amount of work that our team has put into and will continue to put into making the application feel snappy so that you don't even know that you're using a web application. Funny story I remember is when we gave our prototype demo, Sergey Brin, he said to us, "Hey, that's really cool that you guys decided to write this in Flash." So it's got to be fast, it's got to look good, it's got to feel like a desktop application. You're not on Web 2.0, that's so last year. So how do we make the startup fast? Well, I mentioned run async. Get that initial download nice and small. Fast start. We send initial data to the client in the very first HTML page rather than waiting for the communication channel to get set up and then sending the requests. So we send that down so that page appears. We inline images in CSS. So rather than constant HTTP requests, we send that all down using data URLs. Smaller download. This is more a long-term goal for the team. The smaller the download, the quicker your user can get the code. And so this is something we're always trying to work on. Stats collection, we want to know where the slow parts are coming from. And so we rigorously collect statistics and we try and find the bottlenecks and work on them. And recently we added what's called server-side script selection. The way a GWT application traditionally works is you download a piece of code which sniffs using JavaScript what conditions it's in. It goes, what browser are you running? Have you got Gears installed? What language? And then it downloads the correct JavaScript. So what we've done in that case, you have to download something and then an extra round trip before you've even got the first bit of code. Because GWT serves the optimal piece of code, but it needs to know what conditions to serve. So now we just detect all of this on the server side, save you that round trip. So that's startup. Loaded client. Once the client is loaded, we want the experience to be fast. We want waves to jump off the page at you. So optimistic UI, which I mentioned earlier, we don't want you to hang around waiting for clicks to be processed. We want you to be able to get on to the next thing. Prefetching. We fetch waves from the server even though you haven't got them open. We try and guess what you're going to look at next so that it can open quickly. Into the specifics of the coding, we use the flyweight pattern a lot. So you saw this big, long panel, and you can scroll down and up in the contacts. You don't want to create too many DOM elements and JavaScript objects. So what you do is you reuse them. It's kind of like how Google Maps has these tiles that it reuses to create this illusion of the infinite world. We do that too. So we buffer, we call them digests in the search panel and contacts, etc. And then when you scroll down, well, let's reuse those objects and just change the details of them. So that makes things a lot faster. And then rendering tricks. There's a few people in our team now who have PhDs in rendering tricks. It's called learning the hard way. So one piece of advice, which I'm sure the GWT team's been saying as well, is prefer using their DOM classes rather than using GWT's widget class. And the reason you want to do that is because it's kind of like JSOs, you're dealing directly with the objects rather than creating extra references and event listeners. And one interesting bit of trivia that we picked up along the way, you'll notice our panels, they have like these bars up the top. And the way we do that is we have a small little image and we repeat it. So we use background repeat to get that effect. So when you resize it, it's just repeating the image over and over again. And one of our excellent engineers, he discovered, hey, this is really slow in Internet Explorer. I wonder why that is. So he changed the 2-pixel image, stroke of genius, changed the 2-pixel image to a 40-pixel wide image, and wow, fast. So, it's all about knowing, when you use Google Web Toolkit, you still every now and then have to deal with the browser itself. Okay, that's performance, and we're going to continue to work really hard to make this application fast. Mobile client. We didn't quite get to see a great demo of this morning. Well, you got to see it, but you didn't get to see interaction because the network was just being completely slammed. But Lars mentioned earlier today that we managed to build this with what we estimate to be 5% of the effort that was required to build the desktop client. We didn't rewrite in Objective-C and then each different mobile phone, because we're a small team trying to build something fast, and we don't want to have to worry about all these different devices. Thanks to GWT deferred binding, what we do is we just say, well, we've got all these different user agents, but we've got iPhone and Android as well. If it's iPhone, we'll serve the exact same code, except we'll make it look purpose-built for the iPhone or for the Android. So very little effort required. And of that 5%, I think we decided that the majority of that time was actually time spent on work that really benefited the desktop client as well, because the real problem with mobile is the speed. At one point, we set ourselves a goal of the mobile client must start up within 30 seconds. And that was actually a lot of work, surprisingly. But, we're well beyond that particular point in the project. So thanks to us using deferred binding and working away at our mobile client, we actually improved the experience for the desktop client because we had to worry about performance, and you really feel the pain when you're running on a low speed, low memory, low everything, but really shiny mobile device. So for version 1, we think this is what it's going to look like, Ajax only. And to us, the thought of having to port our code, and every time we change it, having to port it to, say, Objective-C, feels like a lot of work, and we're getting so much mileage from just using GWT deferred binding. Interesting bit of trivia we picked up. The iPhone browser is always running. So native apps actually take time to start up, but because the browser is always running, we can actually get our Ajax client started up faster than a native app, which that's kind of interesting. We use a mobile-specific communication channel. So we assume it's a mobile device and it's a bit lighter weight. And we also put some work into, but we haven't quite got it there, into using HTML5 gears to do caching. So app cache, we created a manifest linker for GWT. So basically it generates, when you compile, everything that's required so that your application can be cached on the iPhone. And a bit of trivia there, I'm not sure if it's changed for 3.0, but the iPhone does not cache files bigger than 25 kilobytes. It does not guarantee the caching of these files. And you saw the graph earlier, we're a little bit bigger than 25 kilobytes. So we need to use this. And everyone loves a demo. So let's remind you all. Here we go. Thanks, Ryan. Hey, Adam, good for the win. Alrighty, have we got a... I didn't click that. I blame the emulator. Have we got a David here? Say hello if you're here. I'm going to add Ryan. No, I didn't want to do that. Ryan. Oh, wait, it was rhickman.wavesandbox.com. It's a little bit slower to type on the actual. There you are. I see you. But I'm adding you to this wave because I want you to do some fun collaborative editing. Are you here, Ryan? soon. He's on my mobile phone. So let's edit this one. He's bandwidth challenged. All right, let's have a look at it on the Android. I'm going to talk to myself because I'm the only one in the entire room with a good network connection. Let's see how this works. Still loading on the Android. Hi, Adam. Great talk. Wait for it. It'll come. Work in progress was, I believe, the phrase we were using this morning. It came? Yay. So, mobile. Oh, someone's here. Here we go. He's doing pretty well for bandwidth challenge. You can see the Android emulator is taking a bit of time to keep up, but we presume that's because the iPhone emulator is actually running natively on the machine, whereas emulator emulates everything. So that's what mobile looks like. And we're hoping to make that better and better and better, take advantage of all the wonderful things that a mobile phone has. You know, take a photo, add it to Wave, done. Okay. Next thing I want to talk about is testing. Very important when you're writing a very large application with a lot of moving parts is you want to be able to sleep at night knowing that there are no bugs. And of course we have bugs, but we're working on that too. The guy who wrote the bugs in our project, I think he left. Just a brief note on testability in Google Web Toolkit. Model View Presenter. Please use this design pattern if you're going to write a GWT application. We'd like to think on our team we learned things the hard way. We were pioneering GWT as we were so many different tools. And we reached a point where we just couldn't test our application. You really want to design to separate the concerns. So you want to have your user interface code, the actual stuff that talks to the DOM, separated away from the logic. And you want to be able to test all of that. So use this pattern, Model View Presenter. And why do we do that? Well, GWT test cases let you actually manipulate GWT. You can actually run browser editing code. But JUnit test cases run like this. So JUnit test case, for us, we've been experiencing will run in 1 second, whereas a GWT test case will run in the order of 1 minute. Prefer JUnit test cases. Faster is better. And I'm also going to talk about just now, a big part of Google Wave, we've been working very closely with the WebDriver team. And we need to be able to test what it is actually like in the browser. We need to see that the user interaction works correctly. So what's WebDriver? I'm glad you asked. It's a developer-focused tool for browser automation. And it's, if anyone's familiar with Selenium, it's a similar concept, except we use WebDriver instead of Selenium because it has native keyboard and mouse events rather than synthesizing via JavaScript. So there's actually things that we could not test with Selenium that we can test with WebDriver. And you've seen our editor. We have an extensive test suite that makes sure that the editor type works perfectly. Some challenges we face with WebDriver. We adopted it very early, and as you all know, you sit on the bleeding edge, you bleed. And of course, it's incomplete. So it doesn't quite support all the browsers we want, but it's moving. And we could not do this project without WebDriver. It's an open source project, so feel free to search on Google for WebDriver. And Google Wave is committed to the success of WebDriver. So for each person that the WebDriver team adds, we are adding a person. We want to really build a powerful tool that everyone here can use to test their applications. And some of the things that are new are iPhone driver, so we can actually do automated testing on the actual device or on an emulator, make sure it works as we expect. And remote WebDriver on a grid, so we can farm out our tests and have them run in parallel, nice and fast. And demo. Let's see WebDriver. That never did load. Okay. Yeah. Turns out the WebDriver tests I ran earlier failed, so we've got a bug in our code. So I'm just kicking off the tests, and what you'll see here in a second is the WebDriver test. This is a VNC session. What you're going to see here in a second is the Google Wave client will load up in a browser, in Firefox to be precise, and then WebDriver will automatically start clicking on buttons. Here we go. We always joke that we should have written the entire demo script as a WebDriver test, and then Lars and Steph wouldn't have the whole shaky hand mistyping every word problem. So let's watch. So here we go, Google Wave, we've signed in. WebDriver, do you know your ABC? And this test in particular is checking that the title of the Wave panel matches the text we wrote, add a contact. We've got all sorts of assertions. We're trying to make sure that everything is working as expected. And an added bonus we like is we've got a big TV in our office back in Sydney, and these tests show up very regularly, and just sitting at my desk, I can go, hey, looks like that panel just moved to the other side of the screen. So, really nice having these visual tests, and we're trying to improve the coverage of our application so that the entire thing is covered by a WebDriver test. So this is testing dragging a contact. That's pretty cool. So now we can actually test the drag drop, which used to break all the time. I know the testing team would agree with that one. We're really happy to have that test because that was constantly breaking. And that can go on forever, so I'm going to keep going. So that's what WebDriver looks like. Some tips on writing WebDriver, because of course I'm hoping all of you are going to race home and start using WebDriver, just like Google Web Toolkit and of course Google Wave. Avoid using XPath. So this is how you refer to elements within the page, because it's slow. So it's run actually as JavaScript on Internet Explorer traversing, and it's very brittle. Rather, what you should use is IDs, names, and also if you know that it's in a subtree of the DOM, rather navigate that. Intent of the test should be clear. So use literate programming. Make your tests read like English, so anyone can tell exactly what your code is meant to be doing. And it's a good idea to have for each class in your UI, a corresponding WebDriver helper class. So Wave Panel should have a Wave Panel helper. Search Panel helper. And these should abstract away the concerns of that panel. So, for example, Search Panel should have a method, click new wave. So we don't need to worry about finding the DOM when we're writing our test. And here's an example of what this is straight out of our code base. This is what a test looks like. So blip panel, we call those little elements of conversation blips, equals wave panel get focus blip. So we get the focus one, we get the editor from it, we type, do you know your ABC? Press enter. And your alpha, beta, gamma. You just all saw this with your own eyes. Enter, Bex goes back and then types ... question mark. And then we have an assertion that checks that this is the content of the editor. And we even have this little pipe character to mean that's where the cursor should appear. So it makes it really easy to write powerful editor tests. And then click submit, and then assert that the title of the wave is Do You Know Your ABC? So that was WebDriver. To summarize my talk, I talked about the decision our project used to use Google Web Toolkit, and we are all pretty confident we made the right decision. I covered some basic pieces of our client architecture, the changes that have occurred in Google Web Toolkit over the last 2 years or so, our work to improve gears, and we're committed to making this into HTML5, performance, how to get our app and hopefully your app nice and fast. I showed you briefly the mobile client and how Google Web Toolkit made this really easy for us. Testability, you need to test your applications well automatically, and how we use WebDriver to do this. So thank you very much. So we've got 6 minutes left, but if you have a question, please come up to the 2 microphones and ask away. And I'd love some feedback, so if you could please visit this URL, havasec.com/io. Okay, first question.
Hi. I assume you're using GWT 2.0?
So our team, we've been writing the tip of the open source project. So we've been working.
Do you know when it will be released for general public?
For 2.0?
Yeah.
Any GWT people who want to answer that? When GWT 2.0 will be released to the general public? Okay. I'll get back to you.
Can I get this mic on? Hey, so I'm the product manager for Google Web Toolkit. So hopefully sometime in Q3, but we're an open source project, so you can use Trunk and Tip just like these guys are and other projects within Google and outside of Google.
Thanks, Andrew. Next question?
Could you talk about how the client-side communication mechanism, namely the comment technique you described, works? And is that able to leverage any of the existing GWT functionality like RPC?
So we use this particular piece of Google technology, which is this communication channel. And pretty much the input we just send is text either way, and we send JSON. So we use JSON extensively throughout our system to send it between the client and the server. Does that answer your question?
Sort of. I was just curious how you implement the persistent connection.
I'm sorry, I can't quite
The long-living HTTP connection?
Yes. Well, I guess our future plan for that, we're really hoping HTML5's WebSocket will be a wonderful answer longer term, but that's what we're using at the moment. And it works pretty well.
Is that something we can download and play with? Is there a JavaScript library for that?
I'm not sure. I don't think so. But can talk more about that after the talk. Okay. Next question.
Yes. Have you got any plans to offer the server-side script selection as part of GWT?
That's another one that I'll recommend to the GWT team. So we currently use this quite widely throughout Google. And I think it's a fabulous idea. Everyone should be using this. And yep, hopefully the Google Web Toolkit team will do that.
Also, the manifest GWT linker for app cache, is that available?
Not yet. We haven't quite perfected it for ourselves yet, as you've seen, work in progress for everything. But we would love to open source that, absolutely.
Thanks.
Okay, no further questions. Thank you very much.